So again, taking pictures is a 4-step process. I'm making sure it's on the video, so you guys know what I'm saying. 4-step process in taking photos. To remember the 4-step process, we remember the acronym FAST. F-A-S-T. And F stands for what two things? Focus and focal length. So when we're looking through the lens, we adjust our focal length. We can adjust it to 15 millimeters or 55 or 35, and I'm going to talk a little bit later about which number you would choose. So we choose a focal length, and then we would look through the camera and make sure we adjust the focus so what we see is sharp and clear. So first step, F, focus. What is A? Aperture. Remember, aperture is like the pupil of your eye that can either constrict or dilate to let in more or less light. So we're going to control the aperture, largely dependent upon how bright or dark it is. If we're in a room that's super, super, super bright, what are we probably going to do with our aperture? We're going to probably make it smaller, because otherwise our photos might be too bright. The term we use in photography is we say it's overexposed. So if A is aperture, what is S probably? Shutter speed. We're going to control how long, because in our camera, there's a shutter. When you take a photo, everybody point your camera up at the flat, please. We're going to snap a photo. Turn your camera on if it's not already on. Point your camera up with the flag, and we're going to go ahead and snap a photo. Go ahead and just make sure your SD card is in the camera. All right, so if it's not in there, put it in there now. Once you've done that, point your camera up at the flag. Do that first step, which again is focus and focal length. And then we're going to skip A and S for now. We're going to go ahead and push the button like we're going to take a photo. Snap a photo. And so as you take photos, I can hear something. What do you guys hear as you snap a photo? You hear this click, right? And that click you're hearing is what? It's the shutter. So the shutter is like that door or window. It's closed most of the time. But when you go to take a photo, that shutter opens, allowing light to come through to hit our recording medium. And then when we're done taking the photo, it closes off. And so that click you're hearing is the shutter. So F, focus, A, aperture, S, shutter. What is T? T stands for test. Test. And we're going to talk more about that next week, all right? Because when you adjust your aperture and when you adjust your shutter, you might have made the wrong adjustment. So you need to do a test to figure out if you made the right choices. So that last step that we do before we actually push the button to take the photos, we're going to do a test. And I'm going to talk about next week how to do that. All right. But for now, in your notes, 4-step process for taking a photo. F stands for focus and focal length. A stands for aperture. S stands for shutter speed. And T stands for test. Let's talk about this first step, F for focus. All right. Your lens. The lens in your camera. First of all, there are 4 basic lens types. Please write that in your notes. There's 4 basic lens types. 4 basic lens types. They are, and I'll list them for you first in no particular order. This is not best to worst or whatever, just 4 types. One lens type is a short lens. Short lens. Now, some of these lenses go by other names, so I'm going to give you their synonyms as well. The term I use is short lens. The more common term for a short lens, if you were reading a photo magazine, for example, or you were buying a lens at a photo store, typically short lenses are referred to as wide-angle lenses. So on a test, by the way, if I asked you to list lenses and you listed wide-angle instead of short, that's fine. All right, so the first type is short, also known as wide-angle. So if there's a short lens, there's probably also a what? A long lens. Yeah, so a long lens. The common term that you've probably heard used to describe a long lens is the telephoto lens. So think about those lenses that you see on the end of those SLR cameras at the Super Bowl or at other sporting events, those really long lenses, those telephoto lenses. Again, we use the term long lens. I'm going to explain in a little bit why we call them long lenses. But again, first type, short lenses. Second type, long lenses. Again, another name for a short lens, wide angle. Another name for a long lens is telephoto. The next type is what I refer to as a normal lens. Normal lens. What they are sometimes referred to in other publications as would be a standard lens or a prime lens. Any of those terms is acceptable. There's a reason I prefer the term normal, and I'm going to explain why in just a little bit, okay? And then the fourth variety is what we call a zoom lens. Zoom lens. Okay? The great thing about an SLR camera is, remember before we talked a little bit in an earlier discussion, one of the benefits of the SLR camera over other types of cameras is the fact that you can swap out lenses. I can take this lens off and put a really long telephoto lens on if I wanted to, or I could put a really short wide-angle lens on there if I wanted to. Currently, right now, your lens is equipped with a zoom lens. So this is a zoom lens. It allows me to adjust the focal length, right? So what makes a long lens, or a short lens, a short lens? Let's talk about that, all right? It's all about what's referred to as focal length. Let's talk about focal length. Let me give you some definitions. All right, focal length. I'm going to draw something on the board for you, and I'm also going to show something in our presentation. Pull up a slide in our presentation here. So here we have two lenses. And what we've done here is we're shining laser beams through them so you can see the refraction. Now, when light travels through a lens and it bends inward, where that light, as it bends inwards, comes to a point, which is what you see here. Light traveling through, notice how it comes to a point. We would call that the light is focusing. It's focusing on a point. If the light is diverging, right, defocusing. Both are examples of refraction. All right, both of these lenses are focusing light. Where the light rays focus, where they converge, we refer to that as the focal point, right? So the focal point is the location in three-dimensional space where light traveling through a lens converges, comes together. Okay. Give me a moment to write that down. Sure. So the focal point is the point where light traveling through a lens converges, comes together, where it focuses. So looking at this lens here, illustrated here on top, here's the lens, right? Light travels through it. That's the focal point right there. With me so far? If you were using this lens in your camera, so if you put this lens, so this lens, if it was sitting in your lens housing, light was traveling through it, what would you put right here at the focal point? What goes right there? That's where you put your recording medium. If it was a film camera, that's where you put your film. If it's a digital camera, that's right where you put your sensor, your CCD sensor. I'll get to that in a second. Now, notice this lens down here, though. Okay. Is this lens focusing light? Is the light traveling through this lens converging? Yes. Yes. It's just converging way, way over here. Notice the difference between the two lenses is how close the focal point is to the lens. The difference between these two lenses is what we would refer to as focal length. So another definition, if focal point is the place where the light traveling through the lens converges, focal length is the distance from the lens to that focal point. So if I were literally to take a ruler I were to take a ruler, a measuring stick of some sort, if I were to measure the distance from the lens here to the focal point here, that distance we would call the focal length. In my camera here, right, the lens is here in the lens housing. The recording medium would be back here, which is where the focal point would be. So if I were literally to measure the distance from the lens to the back of the camera, that distance here would be my focal length.
So is that a standard number?
No, no standard number.
That would be the 35 millimeters of the other frames.
If we have it set at 35. So look at your camera, please. Look at your camera lens. Look on top of your lens, and there are some numbers here. 55, 45, 35, 24, 18. Those numbers are focal lengths. Now, they're lengths in what units? Millimeters. So that means when you adjust the lens to 55 millimeters, if I were to literally measure the distance from the back of the camera to where the lens is, it would measure 55 millimeters. And if you notice, as you adjust the lens, as you turn it, notice that the lens gets longer and shorter. In fact, actually, everybody, please take your lens off the front of your camera. If you're using your own camera, please don't do this. It's not good for your lens. If you're using one of my lenses, you can. You're going to take the lens off, so go ahead and take your lens off. And I'm going to hold the lens in front of me. Okay? Hold the lens in front of you so that the proximal end of the lens, the part of the lens that attaches to the camera, is facing you. All right? And then what you're going to do, everybody look at me for a moment so you can see me do this. You're going to turn the zoom collar back and forth, and if you look in there, you're actually going to see that inside the housing, the lens actually moves forward and backwards. So do that. You want to use this one? Use that one. So you guys see that inside the housing? See how the lens moves forward and backwards? So what it's actually doing is it's increasing or decreasing the distance from the recording medium. It's actually increasing the focal length or it's decreasing the focal length. Now, those numbers, by the way, those were metric numbers, weren't they? Yeah. Millimeters. Guess what? I hate to tell you, but if you want to work in forensics, you need to learn to embrace the metric system. Because that's the system that we use in forensics. So instead of making measurements in feet or inches, we make measurements in the metrics. So meters, millimeters, decimeters, centimeters, kilometers. Instead of making measurements in pounds or fluid ounces, pounds or ounces, we use grams, kilograms, micrograms, nanograms. And instead of using volumetrics like gallons or fluid ounces, we use liters, microliters, milliliters. You have to learn to embrace the metric system. So having said that, we need to know what a millimeter is. Because if you look again at your lens, look at your lens, top of your lens, those numbers, 55, 45, those numbers are millimeters. So what is a millimeter? All right. Looking at my yardstick here, it's a yardstick, because on one side it's 36 inches, which is 1 yard. But on the other side, this is a meter. In fact, so you know, a meter and a yard are about the same size. So when we talk about a person running 100 meters, like a 100-meter dash, 100 meters is about the same length as 100 yards. It's about the length of a football field. So there are 100 of these in a football field. So this is 1 meter. So far, so good? But the measurement on there is not in meters, it's in millimeters. So what is a millimeter, right? So if we were to take, milli, by the way, means 1/1000th. So if we were to take this yardstick and slice it into 1,000 small segments, and if you look, there's teeny tiny little lines on here. Each of those small segments is 1 millimeter in width. So there are 1,000 millimeters in 1 meter. To help you understand that in terms of the imperial or English system of measurement, 10 millimeters makes up 1 centimeter. There are 100 centimeters in 1 meter. There are roughly 2.5 centimeters for every 1 inch. Or there's roughly 25 millimeters in 1 inch. I'm a visual learner. I like to think about things visually. So the way I like to remember the metric system, can you guys think of something that's about 1 millimeter wide? So if I were to cut this into 1,000 small segments, each of those segments would be about the width of what? Can you think of an object in your lives that's about 1 millimeter in size? Rice is probably a little too thick. Pencil lead is. Does anybody have a mechanical pencil with them? Can I borrow your strand? Thank you. When you buy a mechanical pencil and you put the lead in there, most mechanical pencil, in fact, right here on Joanna's pencil, I can see it says 0.7 millimeters. That's because pencil lead in a mechanical pencil is just under 1 millimeter wide. It's 0.7 millimeters wide. So the lead of your pencil, mechanical pencil, is about 1 millimeter. I like to cook. I like to eat. So one of the things I always use, the really, really thin spaghetti, like angel hair spaghetti, that's about 1 millimeter wide. Another one, if you take a dime out of your pocket, a dime, the coin, the thickness, not the width of the dime, the thickness of a dime, it's about 1 millimeter. So that means if you were to take 1,000 dimes and stack them, made a stack of them, right, stack them from the floor to that, about 1,000 of them would be about this height. So what that means is, looking at your lens, when you have your lens set at 35 millimeters, that means it's about 35 millimeters from the lens to where the recording medium, or about a stack of about 35 dimes, or about 1.5 inches. Make sense? All right.